Alright, so we have systems of equations, two or more equations graphed together. And so since they're graphed together, the x and y values are the same. So you have the same input for the same output, but maybe you have different situations. I could create a system with you guys, y'all are students, so maybe it was the amount of time you prepared for the last test versus your grades. Any of those that would work. Or we could look at foods and create a system of a certain food and how much you ate of it. Amount of what would go on French toast. So the amount of French toast you ate, how much energy you had. Like that. Alright, so solution. Where all the lines intersect, the points the lines all have in common. And so in just most the last couple of days, you guys have started to look at systems. You had equations. You were finding where they all came together. What's slope-intercept form? Y equals well, we don't assume it is there, but do we write a 1 what's in front of the variable? No, we typically don't, because 1 times a number is just itself, right? So if there's no number here, then we know it's really a 1. So for this one, our slope is and our y-intercept is all right. So our y-intercept -2. What does that mean? How do we graph that? So if I'm graphing this, what do I do with that -2? What is slope-intercept? Slope-intercept is b. Where it crosses the y-axis. Y-intercept where it crosses the y-axis. So what does that mean? Where it crosses the y-axis? Well, it crosses here, but I guess you were explaining what does that mean in terms of a situation. That one setting. It's our starting point where it's our value when x equals 0. That's where we're crossing. Graphing wise is where it crosses our y-axis, and then in a situation, it's our starting point. It's where our situation is when x equals 0. So now, what is slope? What is slope? We talked about Devon's slope yesterday when he runs. what? Well, that's that. But what's the slope in like what is slope? If you were describing it to a middle school student at a track meet, what they're learning about slope, what would you say? Rise over run. What's that mean? How much you go up and then over. So when you go up and over, where are you at then? Okay, with this one, how much are we going up and over? Up one. Up one. What's the slope? What's the slope here? Of these, of M and B, which is your slope? Where's slope-intercept form? You all have your notebooks out. So go to your notebook. Maybe Dalton's line. Go to our notebook and find the lesson where we talked about slope, where we talked about slope-intercept form. I want everybody to be turning in their notebook. I'm going to walk around and I want to see. So we have our slope. So so we have our y-intercept at -2. So how do we apply our slope? How do we get another point on the line? We go not up one, over one. We can. All right, so that's this line, right? All right, so now we need to graph this line. How do we graph y equals -2 plus 7? So first, what's the first thing we need to identify? All right, so what's this called? That's 7, but what's that? Where's the slope? Y-intercept. So this is our y-intercept, and what does that mean? All right, so this is where it crosses the y-axis, our y-intercept. All right, now what? We need to apply the slope. Go down to 1, over 1. We can go up over 1. All right, so this is our graph. So where do these graphs intersect at? I promise. All right, so yours should be drawn better to scale. You've done it on the graph paper, right? Let's graph these on the graph paper. So after graphing both lines, where are they intersecting? What's the point where they cross? So they intersect. All right, so what's the point where they intersect? They intersect at 3, 1. Are they straight lines? Double check your slope. right? So you have now this line here. Where's the y-intercept at? Where's the y-intercept at? Okay. And which equation does this go to? All right. So you do this. All right. So where does our graph intersect at? Where does our graph intersect at? 3, 1. All right. So now let's look at the two graphs below, and I want you to circle where the graph intersects at. So 3, 1. We're going to call it as our solution. And so if we put this point into both equations, it should check out. So now what I want you to do in your notebook on the page on it, like off to the side, I want you to substitute 3. 3 goes in for which variable in our equation? Goes in for x, and 1 is going to go in for which variable? Y. So if we substitute 3 in for x and 1 in for y, we should get a true statement for this equation. When we substitute 3 in for x and 1 in for y into our second equation, we should also get a true statement. It should work not for just one, but it should work for both. So I want you to take a moment and do that right now. We have x coordinates, and then we have 2 sets of y coordinates. So this is the y coordinates for our first line and the y coordinates for our second line. We want to find the solution. When we looked at the solution for our 2 equations and our 2 lines, our 2 graphs, what was true about our x and y coordinates for that solution? Where they intersected, our x and the y coordinates were the same, right? So when we're looking at this table, what are we looking for? We're looking for sameness, right? Where do we see sameness? Where are we putting, where are the same points? So how do we read this table? So if I look at this, my x column, for this line, I have a point at -1, 1. I have a point at 0, -3. I have a point at 1, -7, and a point at 2, -11, and a point at 3, -15, correct? If I look at the second line, these are still my x values. So I have a point at 1, -17. I have a point at 0, -15. I have a point at 1, -13. I have a point at 2, -11. And I have a point at 3, -9. So where do they have a point that's the same? So let's go through. Let's write the points for this that first equation. What's this point? -1, 1. Like this one, we have point at 0. We have point at Now, what point do they have in common? What point is on both lines? Does everyone see that these points are the same? Does everyone see that? So these are our x coordinates. We have this point, but then we also have -1, -17. So if it's easier to break them apart, then what should you do? Break them apart. So look at that other table there and find what point do those two lines intersect. So looking using the table, find that.